ETOPS, or Extended Range Twin Operations, refers to the operation of an aircraft with two engines along routes where the aircraft might be more than 60 minutes away from an adequate airport. The concept was first introduced to address the reliability issues of early piston-powered engines. Back in the 1930s, the Federal Aviation Administration established a rule limiting twin-engine aircraft to routes no more than 100 miles from an adequate airport, which is approximately 60 minutes of flying. This restriction ensured that in the event of an engine failure, aircraft could safely divert to the nearest airport without compromising passenger safety. However, this rule also meant that aircraft had to fly less direct routes, which increased flight times and fuel consumption. As aviation technology advanced, so did the reliability of aircraft engines. The advent of jet engines in the 1950s drastically reduced the likelihood of engine failures. In response, the International Civil Aviation Organization recommended increasing the diversion time for twin-engine aircraft to 90 minutes. While many countries adopted this recommendation, the FAA initially retained the 60-minute rule. It wasn't until 1985 that the FAA introduced a 120-minute diversion time for twin-engine aircraft, allowing airlines to operate longer and more direct routes. This marked the beginning of modern ETOPS regulations. The first official ETOPS operation was conducted by a TW, a Boeing 767, in 1985, though the Airbus A300 had been used under ICAO's 90-minute rule since the late 1970s, making it the first unofficial ETOPS jetliner. These changes allowed airlines to significantly reduce costs by flying shorter routes, cutting down on fuel consumption and flight time. Obtaining ETOPS approval is a highly regulated process. It is not automatically granted, even if the aircraft is ETOPS certified. Airlines must apply to their respective regulatory authorities and demonstrate compliance with stringent maintenance and operational standards. There are two primary methods for obtaining ETOPS approval. The first, accelerated ETOPS approval, is for airlines with no prior ETOPS experience. This type of approval requires the airline to work closely with aircraft manufacturers and demonstrate that they have the resources and systems in place to safely initiate and sustain ETOPS operations. The second, in-service ETOPS approval, is for airlines that already have experience operating specific aircraft and engine combinations. These airlines must provide evidence of their operational reliability and maintenance records to their regulator. ETOPS approval also depends on the airline's ability to maintain a rigorous maintenance program. This includes proven systems for monitoring engine reliability, oil consumption, and propulsion performance, as well as having a plan for addressing technical discrepancies. Airlines must also define their ETOPS routes and identify alternate aerodromes that meet specific criteria, such as having proper ground support, navigational aids, and acceptable weather conditions. Diversion time is a critical factor in ETOPS operations. It dictates how far an aircraft can operate from an adequate airport. For example, an ETOPS 180 approval means that the aircraft can fly up to 180 minutes away from an alternate aerodrome in the event of an emergency. This time is used to calculate the maximum diversion distance based on the aircraft's speed with one engine inoperative under standard atmospheric conditions. Key points along an ETOPS flight include the ETOPS Entry Point, where the aircraft officially becomes more than 60 minutes from an adequate airport. The Equitime Point, which is the midpoint between two alternate aerodromes in terms of flying time. And the Critical Point, where fuel planning becomes crucial to ensure the aircraft can reach the nearest alternate safely. Critical fuel planning is an essential aspect of ETOPS operations. Fuel requirements are calculated to account for various scenarios, including engine failure, pressurization failure, or a combination of both. These calculations include allowances for descent, holding patterns, go-arounds, and multiple landing attempts. Pressurization failures, in particular, can significantly impact fuel consumption, as the aircraft must descend to a lower altitude to ensure passenger safety. The operational procedures for ETOPS flights begin with meticulous flight planning. Dispatchers prepare detailed plans that account for weather conditions, alternate aerodromes, and aircraft performance. Pilots review these plans, ensure all required systems are functional, and determine critical points such as the EP, ETP, and CP. During the flight, pilots continuously monitor weather conditions at alternate aerodromes and verify fuel levels to ensure they remain within ETOPS limits. If weather conditions or fuel levels become unfavorable, the flight may need to divert to a suitable alternate airport. However, once the aircraft has entered the ETOPS segment, pilots have some discretion to continue the flight if it is deemed safe to do so. In summary, ETOPS has revolutionized air travel by enabling twin-engine aircraft to safely operate on longer, more efficient routes. From its origins in the 1930s to its modern regulations, ETOPS has evolved alongside advancements in engine reliability and aviation technology, allowing airlines to offer faster, more cost-effective flights while maintaining the highest standards of safety.